Hello everyone. Now let's look at another LeetCode problem. Today we are looking at problem 121, which is best time to buy and sell stock. Okay, you are given an array prices where prices I is the price of a given stock at the IA. So we have prices where we have array prices. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. So you want to return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. So okay, let me reread the problem description to see if I have any questions. We are given array prices and we need to find a time to buy and then sometime later to sell the stock, and at the end we want to get the max return of our transaction. Okay, so let's look at some example here. Prices 7, 1, 5, 3, 6, 4. So we need to choose a time to buy it. In here I would say we buy at 1 and then sell at 6, and then this gives us a profit of 5, which is correct. So you buy on day 2, price 1, sell on day 5, day 6, price 6, profit is 5. Note that buying on day 2 and selling on day 1 is not allowed because you must buy before you sell. So we are not allowed to swap sell in the sense. You need to buy and then sell. You cannot sell and then buy. And then the second example, we have prices 7, 6, 4, 3, 1. So these are descending order. So we just return 0 because there is no way we could make a profit with such prices array. Okay. I think I understand the problem now. Let me think about possible approaches. I would say if we just set let's say we want to buy on the day 1. Let's look at the first example. Actually, I would like to can assume a few things. So I want to clarify a few things here. Can I assume that prices length that there is always at least two elements inside the prices array? So we are given, well, actually not. We could have 1 to 10 to the power 5. Okay, so in each case here that we could come up is there is only one prices, say 1. The second assumptions that I would like to make is that prices I is valid price, i.e. price has to be larger than 0. And here we are given that prices could range from 0 to 10 to the power of 4. Okay. 0 is reasonable because there is maybe no trade at all at that time, so there's no valid prices. Okay, so if we look at example 3 where there is only one element, then we return 0 directly because there's no way we could buy and sell, because if we buy it, then there is no time to sell it. Okay, so I think problem makes sense to me now. One thing that one approach that I can come up on top of my head is that could pre-compute the maximum prices that we can sell if we buy at say B day, which is the day we buy. So if we look at the first example, 715364, if we pre-compute the maximum prices that we can sell, this would be, got to write the, say, max sell, this would be 4, 6, 7. So if we come up with the max sell, then we can go through the prices array again to determine which day we could buy and sell. So if we take the first day, we have price 7. So if we have 7, then what is the price that we can sell it to? If we look at the second element of max sell, it would be 6. Okay, 6 is at the say 1, 2, 3, 4, 5. And the 5th day we can sell it, so we make a profit of 0 actually. Or let's say, yeah, 0. Let's make it 0 here. Profit 0, and then if we buy at second day, we can sell it at 6, so we get 5. We buy it at day 2, day 3, we buy it at 5, sell it at 6, profit of 1. Then day 3, we could sell it for 6 again, make a profit of 3. At day 5, we won't make any profit, and then day 6, we don't even need to consider that because there is no time to sell. So this looks correct because the profit is we get buy at day 2, then we will return 5. And then the second example here, we have 7, 6, 4, 3, 1. The max sell. I just call it sell at this point, so as to simplify our variable here. So profit here is of 0 because there is no day at the future when the prices is higher. Okay, so I think I am pretty good about this. I'd like to start implementing this unless you would like me to explore further optimizations. Alright, I forgot to mention that the complexity here is O(n) because we only need to go through all the element ones, and then the space would be O(n) as well, because I would need the variable an array to store the price at which we will sell in the future. Okay. So I'm gonna start implementing now. So I'm gonna create a cell array initialized to to the length of the same as prices. Then I'm going to go through the array from the end. So in range, length of prices, -1 to -1 -1. Then, actually I don't need to, 1 second, let me think about it. Okay, so I need to set the last element. So cell of -1 equals prices -1. Because if we have only one day left, then we have to sell it at that day. Otherwise, there is no other time in the future to sell. Then we could set the cell of I equals the max of current price and the maximum of the future prices, which in this case we could use the cell I plus 1 because we are filling in from the back. And then we are gonna look through the array again. This time the I will act as the index. The I will represent the day on which we do the buy transaction. So here, what we can do is, first of all, I'm going to need a profit that I initialize to 0. Then I'm gonna say today profit. I just directly pass into the max function. So profit equals max of profit, and the cell of I plus 1 minus prices, right? Then at the end, gonna return the profit. Yeah. Alright, let me go through the code to make sure I haven't missed anything. First of all, I create the cell array, which is the same size as the prices, and then I'm gonna set the last day of sale as the prices of the last day. Another variable that I'm gonna need is profit. This will represent the maximum profit that we could get. Then I'm gonna fill in the sale array, which is the maximum of the today price and the maximum of any day after the I price, the I day. And I'm doing it from the back so that I don't need to recompute everything. Then I will go through the prices again, and with assumption that I'm gonna buy at day I and then sell. Well, I don't need to care which day I'm gonna do the sell, but I can reuse the sell array to determine the maximum prices that I can sell it in the future of I day. Then at the end, I'm gonna return the net profit. I think let me test the code with our examples to make sure it works as intended. In the first example, I have 7, 1, 5, 3, 6, 4, and then I set the the loss of sale as the same as the prices, which is 4. Actually my iteration start point is wrong. It should be length of prices minus 2, because we have filled in the first one. Otherwise, if we use minus 1, then we will it will be out of access of the list. Okay, so the cell of I would be the prices of I, and then the cell of I plus 1, we take the maximum of it. In this case, it will be 6, and so on and so on until the first day we will have 7, but we don't even need that because we're not gonna sell at that day, but it's fine. Well, one very small optimization is we don't need to fill in the last element, the first element of cell, but that will be very minor. Then in the second for loop, I'm gonna check the maximum profit if I buy at that time. So the maximum profit will be the sell of I plus 1 minus prices of the current day. Then I take the maximum of profit with the current profit. At the end, I will return the profit. I think this should work. So the second loop here, I assume if I buy at 7, the sell at the next day would be 6. So I make no profit and just take the current profit, which is 0, meaning I don't do any transaction. And then the second day, actually something come up on my mind. I think if prices is 0, it's actually an invalid day to buy, because we could not possibly buy with price I is when price I is 0. So let me just skip if the price is 0, then I just not allow myself to buy. So here I'm gonna do if prices of I is larger than 0, then I will try to maximize it. Otherwise, it makes no sense to buy with price 0, which is free. Okay, so if I buy at the second day, which is 1, and then I can sell at 6, so maximum profit is now 5. For the third day, 5, sell at 6, and so on and so on. Well, there is a range issue again. I cannot buy at the last day, so let me update the second loop to length of prices minus 1, and then towards the end I can buy at 6, at 4, so I make no profit, and at the end it will return 5. And moving on to the second example, we have 7, 6, 4, 3, 1, and then the cell array would be 7, 6, 4, 3, 1. Here we notice that the prices are decreasing, so at any point we buy, we would not make any profit. And in this case, we just sit down and do nothing, and at the end we will have 0 profit. Okay, so edge case here is where the prices is just 1, then Yeah, it won't even run anything at this point. The for loop will not enter at all. So profit is 0. What else should we test here? How about the case where we have 0 prices? Let's see. If we have 0, 1, this would be profit is, so the cell array would be 1, 1, and then the profit would be, well, 1. How about we have 1, 0, so the cell would be 0, 1, then the profit would be 0. How about we have 0, 0? In this case, the cell also will be 0, 0, and profit would be 0. Okay, so I think I'm pretty confident that this will work. Let me put it into LeetCode to see if it works. So cell equals 0 on length of prices, and then cell of the last day be the same as the prices of the last day. Then I'm gonna look through the cell array from the back. Set the last element. And just put 0 here. Then cell at I equals next of current prices, and the future sell date, the maximum of future sell date, and the maximum prices of the future. This should be done. Then gonna make a profit variable, and we will look through all the days there. And what we would have is profit equals next of the current profit and the sell future sell date. Don't forget to use the sell plus 1 because we want to use the future maximum sell prices, and subtract by the current price. That would be our profit for today. Then we return the profit. Okay, I missed this again. This should be -1. Yeah. Okay, let's try with the given test cases. Okay, we got a wrong answer. For I in range prices. Wait, no. For I in range length of prices -1. Yep, I think should be good. We have some time to look into it again. Sum of I is prices of I, and the future sell price. Profit is 0. Updated as we buy it today. Profit, yeah. This should be correct. Let me try to submit it. And yep, we got accepted answer. Seems to be quite slow, but our memory is doing pretty well. Let me look at one example that are doing well. Okay. Twice as I is less than twice as j. Or j plus I is less than plus j, c profit is plus j minus plus I. Profit is max of profit and the current profit. And then we increase the j. Oh, I see. But I think this would still end up in the ON time, but it does save up the space complexity because we don't need to use our, in our case, our salary. That is pretty smart here. We pick up I to be the minimum that we have seen so far. And then the j would be the... Okay, so here is how I see this solution. We try to minimize the buy, while at the same time we try to maximize the sell. I think this looks pretty good solution. And it does make sense. Let me try to look at other attempts to see if there is a similar one. Not sure what this is doing actually. Oh, never mind then. I think this is hard-coding some of the test cases. Okay, here's another simple one. Current the prices. Okay. Yeah, I think that's a better solution than mine. Because here it is O1 complexity. Yeah. Is there a solution tab? Oh, it's from official LeetCode. I just realized there is such editorial, but it is premium. Alright then. Yeah. I think you can definitely find a better solution in the other submissions. essentially the space is much more efficient, but the time complexity is the same. Let me think if I want to attempt it with this approach. Yeah, so the solution makes more sense if we look into it. But yeah, I think I'm gonna pass it this time. It's very simple if we look at other solution. So thank you.